All right, 1-2, linear inequalities. We're going to talk about inequalities and something very important, interval notation, solving linear inequalities and applying them. So the first thing we need to talk about is what is interval notation. Back in elementary school, or, before, what you would do is if you had a situation like this with the less than or equal to, you would do a little colored in circle. We don't do that anymore. What you do now is you use brackets. This is a hard bracket. That means less than or equal to. When you write it in interval notation, you go from your smallest number to your biggest number using the brackets. All right, so like here, we've got A is less than or equal to X, so of course we've got the bracket, X is less than B. So since it's just less than, it's like a parenthesis, it's soft. So we've got bracket and soft. And so on. A is less than, so you have soft, and then X is less than or equal to, you have a bracket, and then A is less than X is less than B, so of course you have soft again. Now, X is greater than B, greater than or equal to B, so you have a hard bracket, and if it's greater than or equal to, it goes to infinity. And you can never do a hard bracket on infinity because you can't close it. Infinity goes on forever. Okay, so here's our next one, and then here's less than or equal to. Everything that's less than or equal to A. So again, we have a hard bracket, and it's negative infinity. So once again, you cannot close infinity, whether it's negative or positive. All right, something really important to understand is here. This is written in the wrong way. You should always have your smallest number first and the largest number last. So actually it should be written in this way. Now that it's written in that way, it's really easy to do interval notation. -3, right? -3 is going to be your, it's going to be hard bracket because it's less than or equal to. It's going to be -3 to 5 with a soft bracket. All right, here we go. Write each of the following in inequality notation and graph on a number line. Okay, so we'll start with A and our number line. So we've got -2, we've got 3, 4, this is -3. Okay, so we've got -2 hard bracket, 2, 3. So it's everything in between those. Let's see, if we wanted to write that also in inequality, why not do it in that way too? We've got -2 is less than or equal to X, which is less than 3. All right, next one is B. So we'll draw our number line. We're going -5, -4, 0, 2, 3. All right, so here we're going -4 soft bracket to 2, writing that in inequality. -4 is less than X, which is less than 2. All right, next one, let's do C. Do our number line. All right, so we got -3, -2, 0, 2, 3. All right, so here we go. We've got -2 hard bracket to infinity, so it's everything on. Okay, and finally D. Let's do a number line. So we've got 4, 3, 0, so on. And so with D, we're going from negative infinity to 3, so 3 is soft, and it's everything less than 3. So our inequality would be X is less than 3. All right, it's your turn. Go ahead and pause. Let's see if you can get it right. All right, so here's the answers. Hope you got it right. Let's move on. Okay, union and intersection. What the union means is that you're looking at these numbers and you're trying to figure out what everything goes on that number line. So if I've got, let me do blue, if I've got 1, 2, and 3, so there's 1, there's 2, and there's 3, and then I've got union 2, 3, 4, and 5. So all together I've got these 5 numbers. All right, now intersection. Intersection is what do they have in common. So if I've got 1, 2, 3, and then I see where the ones they have in common, 2, 3, 4, and 5. So the answer is 2 and 3. So let's do number 2. It says if A is from -2 to 5, so let's see what we've got. We've got -3, -2, and then we've got 4 and 5. So we're going from -2 to 5. It's everything in here. And B is 1 to infinity. Okay, so B, so I'm going to put in red. B is from 1. Okay, so 1 to infinity. What you're going to do to graph that graph sum, and then to write the union, A union B. So for union, we want everything that's included. So for that, we've got from -2 to infinity. That includes all of these numbers. Okay, so for intersection, all right, now we need to see where they intersect. It starts right here at 1, which is not included, so it's soft, and it goes all the way to 5 included. There's your intersection. All right, your turn. Go ahead and pause. Let's see how you do. All right, here's the answer. Hope you got it right. Okay, solving a linear inequality. So to solve these, first thing we've got to do is just kind of get x on its own. So let's just go through and solve it like we know how to do. So the first thing we do is distribute our 2. So we get 4x plus 6 minus 10, which is less than, and distribute 6x minus 12. Now you know how I love minuses, not plus a negative, plus a negative. Okay, now here I'm going to combine my like terms, and I get 4x plus -4 is less than 6x plus -12. Get my x's together. -4 is less than 2x plus -12. Add 12, add 12. And we end up with 8 is less than 2x, divide by 2. So x is greater than 4, or let's put it in the right order. X is greater than 4. All right, so that solved it. Now what we want to do is we want to go ahead and graph it and put it in interval notation. So to graph it, x is greater than 4. Oops, that's not right. I'm going the wrong way. Okay, so this is 3, 4, 5. Okay, x is greater than 4 is going to be like this forever. For interval notation, you would do soft 4 to infinity. All right, your turn. Go for it. Go ahead and pause. All right, here's the answer. I hope you got it right. Okay, solving a linear inequality involving fractions. Now, we know everybody loves fractions, right? Wrong. Okay, I do, but not everybody. So what we're going to do first is get rid of the fractions. Remember I told you how to do this. You got to look for the common denominator between 4 and 3. Common denominator would be 12. So I'm going to multiply every single term by 12. So that gives me 2x minus 3 over 4 times 12, right? Plus 6 times 12 greater than or equal to 2 times 12 plus 4x over 3 times 12. Because now what you can do is you can make these fractions where you need to, and you can simplify. So 4 goes into 4 once, and 4 goes into 12 3. So that now I've got 3 times 2x minus 3 plus, okay, 6 and 12 is what, 72? Greater than or equal to 2 times 12 is 24 plus, and now here we're going to cancel. 3 goes into 3 once, 3 goes into 12 4. So I've got 4x times 4. Okay, distribute. 6x minus 9 plus 72 is greater than or equal to 24 plus 16x. All right, plus a negative. So combine 6x plus 63 is greater than or equal to 24 plus 16x. Subtract 6x. So that I have 63 is greater than or equal to 24 plus 10x minus 24 minus 24. All right, and so we got 39 is greater than or equal to 10x. Let's make ourselves a little room. All right, divide by 10. And we've got 3.9 is greater than or equal to x, or putting it in the correct order, x is less than or equal to 3.9. Okay, now we're going to graph this. So here is 4, here's 3.9, here's 3. Close enough. All right, x is less than or equal to 3.9, so it's a bold bracket, and it's everything less than or equal to. In interval notation, that would be negative infinity to 3.9 included. All right, it's your turn. First thing, get rid of the fraction, then it's simple. Go ahead and pause. All right, here's the answer. Hope you got it right. Solving a double inequality. There's two things you can do. You can break it up, or you can keep it together and try it that way. So let's keep it together and see what happens. But sometimes it's better to break it up, especially if you have to divide by a negative. Actually, you know what? Let's break it up. So to break it up, here's what you do. You say, okay, there's this part, and then there's this part. So I've got negative 3 is less than or equal to 4 minus 7x, and my other one is 4 minus 7x is less than 18. If you break it up, you can never go wrong. All right, so I'm going to go ahead and start solving. So I'm going to subtract 4, so that I get negative 7 is less than or equal to negative 7x. Now, don't forget your inequalities. Big old alarm goes off in your head. When you divide by a negative or multiply by a negative, you have to flip your inequality. So divide by negative 7 so that you get 1, flip this, greater than or equal to x. Okay, let's put it in the correct order. X is less than or equal to 1. All right, let's go do the other one. So minus 4, and I've got negative 7x is less than 14. Okay, here we go. We are dividing by a negative. So I get x, don't forget to flip, and this is negative 2. All right, so now all I have to do is put it on a number line. So if I put it on a number line, I've got x is less than or equal to 1. So here's 2, here's 1. So x is less than or equal to 1. And then the other thing I have is that x is greater than negative 2. So here's negative 3, here's negative 2, here's negative 1. And so x is greater than negative 2. So here is our solution set. We can put it together now and say negative 2 is less than x, which is less than or equal to 1, or negative 2 to 1 included. Okay, so you say, why break it up? Because sometimes when you're dividing by a negative or multiplying by a negative, it will split up your graph. All right, go ahead and pause. It's your turn. All right, hopefully you got it correct. Now, if you didn't want to split it up, that's fine too. Matter of fact, well, maybe I should show you in case you don't want to split it up. So let me show you real quick. If you don't want to split it up, let's put this over here and make ourselves some room. And you have negative 3 is less than 7 minus 2x, which is less than or equal to 7. So we're going to subtract 7 from all sides. So you get negative 10 is less than negative 2x, which is less than or equal to 0. And now you got to divide everything by a negative 2, and so that big old alarm goes off in your head. So we got 5, switch your inequality, x, switch your inequality, 0. So x is greater than 0 but less than 5. So if you'll notice, this is in the wrong order. So 0 is less than or equal to x, which is less than 5. Always goes smallest to biggest. You'll notice we have the exact same thing. Okay, yay, word problem. In chemistry experiment, a solution of hydrochloric acid is kept between 30 degrees and 35 degrees Celsius. That is, 30 is less than or equal to C, which is less than or equal to 35. What is the range in temperature in degrees Fahrenheit if the Celsius-Fahrenheit conversion formula is right here? So notice it says C is equal to this, so replace your C. So you have 30 is less than or equal to 5/9 F minus 32 less than or equal to 35. Okay, two things we can do here. We can distribute the 5/9 through or get rid of the fraction. I'm going to get rid of the fraction. The common denominator is 9. Notice that the 5/9 is attached to this, so it's like you're multiplying the whole thing. 9 times 30 is 270, which is less than or equal to 5. The 9's go away. F minus 32, less than or equal to 315. Now, I can distribute the 5 through, or let's just get rid of it. Divide by 5. So we've got 270 divided by 5, which is 54, is less than or equal to, these cancel, F minus 32, less than or equal to 315 divided by 5, which is 63. Add 32 to all sides, and you get 86 is less than or equal to F, which is less than or equal to 95. All right, now that we have that done, that pretty much tells you what your Fahrenheit has to be, between 86 and 95. It's your turn. Go ahead and pause. Let's see if you get it right. All right, here's the answer. I hope you got it. Notice I didn't get rid of my fraction until I had to. So I hope this is going to be easy for you. If not, don't forget, make sure you put stars or something by your questions. Make sure you go to my website and go to the calendar to see what problems to do for this section if you're not going to be in class. Otherwise, you'll do them while you're in class.